Let us continue our learning of the subject Advanced Machine Learning, meant for MTech first semester students. We are into Unit 1 and linear algorithms introduction we have done, and linear regression concept also we have learned. So today we'll have a discussion of linear regression example problem, and for this we are referring the prescribed syllabus textbook by Jason Browley. The name of the textbook is Master Machine Algorithms. This is the textbook from which today's contents and the recording are derived. The name of the textbook is Master Machine Learning Algorithms, and the author is Jason Browley. So let us continue our learning. So simple linear regression relationship is given in this form: y is equal to b0 plus b1 into x. Y here is the output variable which is to be predicted, and x is the input variable. X is the input variable, and here b0 and b1 are called as the coefficients. Okay, here b0 is the intercept. Why it is called as the intercept? Because it determines where the line intercepts the y-axis. In machine learning, this is also called as bias. So your b0 will be called as intercept, or your b0 will be called as bias. Why it is called as a bias? As it is added to offset all predictions that we make. Here b1 is called the slope because it defines the slope of the line, or how this x translate into a y before we add our bias. So we are clear about what b0 and b1 are. Both of them are coefficients, but b0 is intercept or a bias, and b1 is the slope. So these are our points, let us say x and y. X, the values of x are 1, 2, 3, 4, 5, and the values of y are 1, 3, 3, 2, 5. Now if you plot a graph, this may look like this, and you can have this line kind of this kind of line. Now you can calculate b1 using this formula, where xi is all the values of x starting with 1 till 5, and we are taking the summation of all of them, and mean of x. So basically what we are doing is x minus mean of x for all the values of x and their summation. Similarly, y minus mean of y for all the values of y, the summation. The denominator is xi minus mean of x. This will be whole square. Again, this will be the auto summation. This will be the auto summation. Once we calculate b1, b0 can be calculated using this formula. b0 is equal to mean of y minus b1 multiplied by mean of x. So we know that the mean of x will be 3. So 1 plus 2, 3, 3 plus 4, 7, 7 plus 3, 10, 10 plus 5, 15, 15 divided by 5, 5, that will be 3. So mean of x is 3. So the values of x are 1, 2, 3, 4, 5. What we are doing is we are going to calculate x minus mean x. 1 minus 3 is minus 2, 2 minus 3 is minus 1, 4 minus 3 is 1, 3 minus 3 is 0, and 5 minus 3 is 2. Similarly, mean of y is 2.8. So for all values of y, we are calculating y minus mean of y. Say 1 minus 2.8 is equal to minus 1.8. 3 minus 2.8 is equal to 0.2. 3 minus 2.8 is equal to 0.2. 2 minus 2.8 is equal to minus 0.8. 5 minus 2.8 is equal to 2.2. Now we know x minus mean of x, and we know y minus mean of y. So this part we know now. X minus mean of x, y minus mean. So we have to multiply them. So this is the multiplication of all of them. Once we multiply all of them, we get this term, and now below the denominator term is x minus mean of x. So x minus mean of x will be this much, minus 2 minus 1 1 0 2. Okay, this is x minus mean of x. The same one, minus 2 minus 1 1 0 2. The square of that will be this much, 4 1 1 0 4. So that brings our denominator term. So now we can calculate the b1 value because we know the numerator and we know the denominator. So b1 will be 8 by 10. b1 will be 8 by 10, which is 0.8. Once we know b1, we can calculate b0 by using this formula, mean of y minus b1 mean of x. So that comes to 0.4. So we have b1 value as 0.8, b0 value as 0.4. Now this relationship can be indicated as y is equal to b0 plus b1 into x. So that will be y is equal to 0.4 plus 0.8 into x. So now we can predict the value of y using this, because x values we know 1, 2, 3, 4, 5. So when we predict the value of y, we are getting them as 1.2, 2, 3.6, 2.8, 4.4 against the actual values of y being 13325. So we have the actual value y now and the predicted value y. Right? So we need to estimate the error. For estimating the error, we'll be using this RMSE. RMSE stands for root mean square error. So this is the formula for this. Again, same thing, you have to take the summation of predicted minus actual value of y square divided by numbers, total numbers that will be. So these are the predicted values. This is the actual y values. Predicted minus y will be this much. Now the square of that will be this much. We'll be taking the sum of all of them, that comes to 2.4, and we'll be dividing it by n. And the value of n will be 5. So 2.4 divided by 5 will be getting us something 0.692. It means what? Every prediction of y is wrong by about 0.692 units. The other way of calculating b1 is we can use this formula, correlation of x comma y multiplied by standard deviation of y divided by standard deviation of x. If you're using Excel, so you can use say correlation function directly, or you can use Pearson's correlation here. And in Excel you have standard deviation functions also. So this is what is today's focus of discussion. Thank you.